Welcome to the AI Research Roundup. I'm Alex. Today, we're looking at a paper from the Hugging Face trending list, published on January 11th, 2026, just 2 days ago. It introduces VideoDR, the first benchmark that specifically tests if multimodal agents can extract visual clues from a video, and then successfully perform deep research across the open web to verify them. The paper is titled Watching, Reasoning, and Searching, a video deep research benchmark on open web for agentic video reasoning. And, as we'll see later, the results uncover some critical stability issues where agents lose track of their original visual goals during long web searches. And for those interested in the implementation, the authors have shared their code on GitHub. Figure 1 illustrates the comprehensive construction pipeline for the benchmark, which is split into data annotation on the left and quality control on the right. The process starts by sampling videos across domains like geography and technology, and then carefully designing questions that require tracking visual cues across multiple frames. Crucially, the right side details the dependency testing mechanism, where any question answerable solely by the video or solely by web search is immediately discarded. This rigorous filtering ensures that the final 100 tasks strictly require integrating both visual evidence and external knowledge. So, while the previous figure showed how the benchmark was built, Figure 2 brings it to life with a concrete example. The question at the top asks for the registration number of an artifact closest to the main entrance. Looking at the left side, the video frames provide visual anchors like the building's exterior, but they don't contain the answer itself. To solve this, the agent must identify the location as the British Museum, search for the exhibit list online, and cross-reference the video's spatial cues with a web-based map. As the flow on the right shows, this multi-hop process narrows down candidates to one statue and finally retrieves its ID, WB67. Alright, Figure 4 breaks down the core statistics of the dataset. Starting on the left, Panel A shows a diverse category mix, with daily life taking the biggest slice at 33%. In the middle, Panel B plots question length, which averages around 26 tokens to keep the queries concise. Finally, Panel C on the right reveals a long-tail distribution for video duration, ensuring models are tested on both short clips and longer footage. Now, Table 1 compares performance across difficulty levels, low, mid, and high. We see the two paradigms side by side, workflow on the left and agentic on the right. Gemini 3 Pro Preview takes the top spot, hitting 76% average accuracy in the agentic setting. But looking at the high difficulty columns, there is a catch. GPT-4o's performance drops significantly in the agentic mode, falling from roughly 47% to 28%. This indicates that on harder tasks, some agents lose focus without the structured steps of a workflow. Table 2 then breaks this down by video duration. Following that duration analysis, Table 3 slices the results by semantic domain, revealing where each approach shines. We see categories like history, geography, and technology listed across the top. In the technology column, Gemini 3 Pro Preview jumps significantly in the agentic setting, rising from about 64% to nearly 86%. The authors suggest this is because tech questions often need precise visual details that the agentic mode preserves better. However, looking at the geography column, the trend flips. Here, Gemini drops from 70% in workflow to 50% in agentic, likely because geographic search needs the stability of a fixed query to avoid drifting off track. Okay, finally, Table 5 digs into the specific reasons why these models fail. What jumps out immediately is the reasoning column near the right side. It is largely filled with zeros and ones, meaning the models almost never fail at the logic part itself. Instead, the real bottleneck appears in the categorical column on the left, which tracks how often the model misidentifies the initial visual object. For instance, Mini-CPM v4.5 in agentic mode commits 36 errors here, the highest count in the table. We also see persistent struggles in the numerical column. Even Gemini 3 Pro Preview makes 6 numerical errors in the agentic setting, showing that precise counting remains a challenge for everyone. Wrapping up, 2 takeaways stand out. First, the fully autonomous agentic approach is not yet a silver bullet, as models often lose track of visual clues during long searches. Second, this prevalence of goal drift suggests that future work must focus on stability over long horizons, rather than just raw reasoning power. That is it for this episode of the AI Research Roundup. I'm Alex, thanks for listening.